So here I'm in my IntelliJ in presentation mode, and let's start solving this problem. I will take the same method name as given in lead code. Just mark it as final to make the arguments immutable. Okay, so here in our previous video, we have come up with this approach or algorithm that we need to check for even length and odd length and try to expand from center. So let's start implementing it. But before that, let's check for a very base case that we have given that the s of length, I mean that input string, can be starting with one character only. So if it's only one character, then we can just return it, right? Just return the string. So it's the same case as dp of 0, that when whatever the string is there, we just return it. So let's implement this base case first. If s dot length 1, then return the string itself, right? Now we start with like maintaining this L and R, which I mean taking the center and trying to expand from center, and then find the maximum length palindrome with the maximum length. So I will use variable as start 0. Start with the 0th index and end is equal to 0. These two variables I will choose for all the overflow conditions, and start with this basic from 0th length to the whole input string length. And then I will not create like if and else condition that if the length is odd or even. Instead of that, I will assume I will start when I start from the 0th index to the last index. So when I start from 0 to covering the whole string input. So I will check both the cases at the same time. I mean whether it's odd length or even length, and then we just compare which is the maximum length out of both the cases. So let me show it first. So I will create first len1, and I will just create a method which will expand from around center, right? Maybe better to write as expand from center, right? We are expanding from there, and we pass original string. And for the odd case, right, it can be only like one character starting at the center. For even cases, we are having two. I've put it here as well for even length. So we have to take two characters as center, right? So I will first of all let me cover for the I. So I and I should be same. I mean the left and right pointers. This is for odd length, and for even length, I will take the left character, and then right character would be I plus 1. Starting from this, if you are taking this, it should be I and I plus 1, these two. This is for even length, right? So let me first of all implement this. So we have been given, I will mark it as left, and this would be right. And again, as I have always been saying that I want the code to be clean and good, so I will mark these arguments as final again. Okay, and let's implement this approach here, that if L is equal to R, and then we iterate R to 1 and L is equal to I minus 1, and we compare going forward. So I will take this as our left, right, and int of R is right, the right argument which is given. This one, we already provided that. And now we will just use the same algorithm that we have discussed. So we have to check for the base condition first, that if we are moving here, if L is because we are subtracting L like for each of the iteration, it should not be overflowing. It should not go beyond the 0th index. This is what the condition says. If L is greater than or equal to 0, and R, these are the overflow conditions. R is less than s dot length, because we are increasing R here, right? We should not be overflowing it from this side. Always less than this. So this is one condition, and I will mark it these overflow conditions in as one group in parentheses. Okay, and now the basic this part, whether palindromes are matching or not. If we are at the same center point, then it will always be matching, and if we are moving, then we have to compare and expand from there. So s dot use s.charAt function in Java for getting a particular index character there, and should be if only it's matching with R, then only we will expand our from center. So we will do L minus minus and R plus plus. Right. This is a very basic, simple approach that we have already deduced in our previous video, and we move only when these characters are matching. These characters are matching here. Let's see. Again, I will just to avoid any operator precedence, I will just put it here like this. So we reformat it. Okay, and now we have to return the length, that the maximum length we have found. So it would be R minus L, right? But because the array start from 0, so we have to also reduce 1, right? So for example, in this case, right, say BAB, once we have found that length of 3, the R would be at this point would be 0, 1, 2, right? And it would be 0, sorry, it would be 0 here. So if we do 2, and for the last condition, it would be already overflowing. So R would be at that time would be 3, and it would be minus 1. So 3 minus 1 that we get the length of 3 then, right? So this is how we created this function, same as what we have discussed. And now we have covered the both cases, odd and even length, right? Now we have found both conditions, odd and even. We are not creating it any even else condition as we discussed. Now we have to take what is the maximum length found, right? Out of these two for both the cases of odd and even. So we'll take len 1, len 2, and again we have to check the condition that it should not be overflowing. So it should be and minus start. Just notice that and start, this is for the whole of the algorithm, not just for a particular index. So this is where we'll be maintaining our final result. It would be start is equal to I minus len minus 1 divided by 2, right? Here what we are doing is, for example, if we have found, say for example this case, right? If we have found this E and E are matching, I mean if we have extracted this particular substring, in that case, what we are doing is, we are doing I minus len minus 1 by 2. So its length here is 1, 2, 3, 4. 4 divided by 2, which is 2, and I minus 2 would, so we have to point basically here, this point. So if we do this calculation, we will come up from here, I minus 2 would be here at this index. So this is our start, which we have to extract. I mean, we have to extract this E, L, L, and E, right? We have to extract this portion. And we are currently here. And then that's how we are calculating this using this formula. Okay. Similarly, end would be I plus len by 2, because we have to move from here to this part, right? So we are starting from here, I plus 2 is this one. So this is how we extracted by using this formula. If you rerun it for different cases, you will see that once we're running for odd length or even, it doesn't matter. So start and end by using this calculation, I minus len minus 2 and I plus len plus 2 will be actually extracting the substring that we have already found, which is a palindrome. This is the length of it. So we are just extracting, moving our pointers so that we get the exact palindromic string. Once we are done with this, then yeah, that's about this algorithm. We already expanded. We have found the maximum length by using this formula, and this is the string that we are already coming up with the maximum length of the palindrome found so far. And then we'll just return this. Return. We use substring. So substring is start is inclusive, and because the begin index is inclusive and the end index is not inclusive, so that's why I'm using end plus 1, so that we get exactly till end. So this is all the algorithm that we discussed, and let's run it for the cases given. So I will take from lead code both the cases that we have been given here. So longest. So I just copied the same inputs as was given in lead code. So let's run this. So it's ABA and BB. So this is what expected. It can be either BAB or ABA. So our solution is working.